Question 1. A sterile processing department, SPD, technician is preparing to soak a heavily soiled Fraser suction tube in an enzymatic detergent. To ensure the effective breakdown of internal organic soils, how should this cannulated device be positioned in the soaking basin? A. Always horizontally to prevent internal fluid pressure buildup. B. Always vertically to allow gravity to pull residual soils out. C. Position to ensure the lumen is completely filled with fluid and free of trapped air bubbles. D. Angled precisely at 45 degrees with the distal tip pointing upwards. Correct answer C. Knowledge point explanation. Core rationale. When soaking instruments with lumens, there is no absolute requirement for a horizontal or vertical orientation. The critical clinical objective is to guarantee that the cleaning solution makes complete and continuous contact with the internal walls of the lumen. The technician must manipulate the instrument to expel all air, ensuring the channel is fully flooded with the enzymatic solution. Trap analysis. Option A is incorrect because a strict horizontal position might trap air pockets in curved sections of the lumen, preventing the detergent from reaching the soil. Option B is incorrect because while vertical soaking can sometimes help, it is not an absolute rule. The basin size and instrument length dictate the physical setup. Option D is a fabricated distractor with no clinical basis in standard instructions for use, IFU. Concept extension. Lipase is the specific enzyme added to detergents to break down lipid fat deposits commonly found in orthopedic surgical instruments. Question 2. During the daily performance verification of the decontamination area, an educator observes the mechanical action of the ultrasonic cleaner. The machine utilizes high-frequency sound waves to create microscopic vacuum bubbles that implode on the surface of a soiled needle holder. What is the technical term for this physical cleaning action? A. Impingement. B. Emulsification. C. Cavitation. D. Deionization. Correct answer C. Knowledge point explanation. Core rationale. Cavitation is the fundamental operating principle of an ultrasonic cleaner. High-frequency sound waves travel through the water, creating alternating high and low pressure areas. This generates millions of microscopic bubbles that expand and rapidly implode, burst inward, creating a vacuum that actively pulls tiny soil particles out of box locks and serrations. Trap analysis. Option A, impingement, is the spray force mechanical action used by automated washer disinfectors, not ultrasonic cleaners. Option B, emulsification, is the chemical process where detergents break down and suspend fats and oils in water. Option D, deionization, is a water purification method that removes charged mineral ions, completely unrelated to mechanical cleaning action. Concept extension. Degassing is the mandatory process of running an empty cycle in a freshly filled ultrasonic cleaner to remove excess dissolved oxygen, which would otherwise cushion the implosions and weaken the cavitation energy. Question 3. An SPD technician is manually cleaning a heavily soiled bone rongeur. To comply with Occupational Safety and Health Administration, OSHA, standards and minimize the risk of inhaling airborne pathogens, what specific scrubbing technique must the technician utilize? A. Vigorously brush the instrument at a 90-degree angle directly above the sink basin. B. Perform all brushing motions while the instrument is fully submerged under the water surface. C. Utilize a rigid brass bristle brush to expedite the immediate removal of organic debris. D. Rinse the instrument with hot water at 140 degrees Fahrenheit prior to the manual scrubbing process. Correct answer B. Knowledge point explanation. Core rationale. Submerging instruments during manual cleaning is a critical infection control mandate. Brushing devices above the waterline generates aerosols, microscopic airborne suspensions of contaminated water droplets. Keeping the friction action underwater safely contains these droplets, protecting the technician's respiratory tract from hazardous biological exposure. Trap analysis. Option A directly violates safety protocols by actively creating a hazardous aerosol plume in the technician's breathing zone. Option C is incorrect because brass brushes are severely abrasive and will destroy the protective passivation layer of standard stainless steel surgical instruments. Option D is a critical error. Hot water, e.g., 140 degrees Fahrenheit, will instantly coagulate protein-based soils like blood, permanently baking them onto the metal surface. Concept extension. The decontamination area must maintain negative air pressure to ensure airborne contaminants do not drift into clean hospital corridors when doors are opened. Question 4. Which of the following mechanical forces is primarily utilized by an automated washer disinfector to physically remove gross bioburden from the external surfaces of surgical instruments? A. Ultrasonic cavitation. B. Water impingement. C. Thermal oxidation. D. Chemical emulsification. Correct answer B. Knowledge point explanation. Core rationale. Automated washer disinfectors operate similarly to commercial dishwashers, relying on impingement. Impingement is the mechanical action of highly pressurized water forced through rotating spray arms. This forceful kinetic energy physically blasts organic soils away from the instrument surfaces. Trap analysis. Option A is the specific operational mechanism for ultrasonic cleaners, designed for microcrevices, not washer disinfectors. Option C is a fabricated term in this context. Thermal energy is used for disinfection, not the physical removal of soil. Option D refers to the chemical breakdown process performed by detergents, completely separate from the mechanical spray force. Concept extension. To ensure proper impingement, technicians must use low-foaming detergents in automated washers. High suds will cushion the water pressure and suffocate the rotating spray arms. Question 5. When a surgical instrument is identified as mechanically defective in the operating room and tagged for external repair, what is the mandatory processing protocol before it leaves the healthcare facility? A. It must be carefully wiped down with a surface disinfectant and placed in a sealed biohazard bag. B. It must immediately bypass the decontamination workflow to prevent further mechanical damage. C. It must be thoroughly cleaned and decontaminated to protect external personnel from exposure. D. It must be flashed in a pre-vacuum steam sterilizer without prior manual enzymatic cleaning. Correct answer C. Knowledge point explanation. Core rationale. All medical devices, regardless of their functional status, must be considered biohazardous after use. It is a strict federal occupational safety requirement to fully clean and thermally or chemically decontaminate broken items before dispatching them. This protocol guarantees that repair technicians and transport couriers are not exposed to bloodborne pathogens. Trap analysis. Option A is insufficient. Surface wiping cannot adequately remove gross bioburden hidden in box locks or serrations. Option B is a dangerous violation. Bypassing decontamination directly exposes unsuspecting personnel to infectious diseases. Option D violates the foundational rule of sterile processing. You cannot sterilize a dirty instrument. Soil will bake onto the device and protect underlying microorganisms. Concept extension. Once a repaired instrument is returned to the facility, it must undergo the complete decontamination, inspection, and sterilization cycle again before it can be placed back into surgical circulation. Question 6. A sterile processing department, SPD, technician receives a battery-operated orthopedic drill from the operating room, or. According to standard protocols, how should this powered surgical instrument be processed in the decontamination area? A. Completely submerge it in a 140 degrees Fahrenheit enzymatic solution for 5 minutes. B. Process it through an automated washer disinfector using a low-foaming detergent. C. Strictly manually clean it according to the manufacturer's instructions for use, IFU, without fluid immersion. D. Flash sterilize it immediately to melt away gross bone and tissue debris. Correct answer C. Knowledge point explanation. Core rationale. powered surgical instruments contain complex internal electrical and mechanical components. As a universal rule, they cannot be submerged in liquid or processed in automated washers unless explicitly stated otherwise by the manufacturer. Fluid invasion will destroy the motor. The technician must follow the IFU meticulously, which almost always dictates a careful, targeted manual cleaning process. Trap analysis. Option A is incorrect because submerging a powered drill will flood its internal housing, causing irreversible damage to the electrical circuits. Option B is incorrect because the impingement force and high volume of water in a washer disinfector will similarly penetrate and destroy the unsealed power components. Option D violates a core principle. Sterilization must never replace cleaning, and flashing a dirty instrument simply bakes the biological soil onto the metal. Concept extension. When cleaning powered equipment, technicians must also ensure the device's safety switch is engaged and the battery is removed to prevent accidental activation and injury during manual scrubbing. Question 7. A sterile processing quality assurance coordinator is auditing the decontamination workflow. What specific methodology is utilized to objectively verify that a stainless steel retractor has been effectively cleaned before it is sent to the preparation area? A. Measuring the water temperature of the ultrasonic cleaner to ensure it remains below 140 degrees Fahrenheit. B. Conducting an adenosine triphosphate, ATP, swab test to detect residual organic cellular matter. C. Performing a Bowie-Dick test in the washer disinfector to monitor air removal. D. Checking the concentration of the neutral pH detergent using a chemical indicator strip. Correct answer B. Knowledge point explanation. Core rationale. Visual inspection alone is insufficient because microorganisms and microscopic biological films are invisible to the naked eye. An adenosine triphosphate, ATP, test uses a swab to detect ATP, a molecule present in all living cells, like blood and tissue. A high reading provides objective, measurable data that organic soil remains, requiring the instrument to be re-cleaned. Trap analysis. Option A is an equipment parameter check, not a direct verification of soil removal on a specific instrument. Option C is incorrect because a Bowie-Dick test is used to detect air leaks in dynamic air removal steam sterilizers, having absolutely nothing to do with washer disinfectors or cleaning verification. Option D only verifies the chemistry of the bath, not the actual cleanliness outcome of the physical device. Concept extension. Lighted magnification is another required method for cleaning verification, allowing technicians to spot tiny fragments of debris or damage hidden in the serrations or box locks of an instrument. Question 8. Regarding the functional capabilities of standard ultrasonic cleaners used in the SPD, which of the following statements is clinically accurate? A. They utilize impingement force to thermally disinfect surgical instruments. B. They provide a complete decontamination cycle including a final critical water rinse. C. Their primary function is mechanical cleaning via cavitation, lacking a thermal disinfection phase. D. They are exclusively designed to process flexible fiber optic endoscopes. Correct answer C. Knowledge point explanation. Core rationale. A standard ultrasonic cleaner is strictly a cleaning machine, not a disinfector. Its sole mechanism is the creation of microscopic imploding bubbles, cavitation, to physically dislodge fine soil from difficult-to-reach crevices. It does not typically possess the heating elements or cycle phases required to achieve thermal disinfection or perform automated rinsing. Trap analysis. Option A is incorrect because impingement, water spray force, and thermal disinfection are the hallmarks of a washer disinfector, not an ultrasonic cleaner. Option B is incorrect because standard sonics lack rinsing capabilities. Items must be manually rinsed after removal from the sonic bath. Option D is a dangerous falsehood. Flexible endoscopes are highly delicate and are generally prohibited from ultrasonic cleaners, as the intense vibrations will destroy their internal optics and channels. Concept extension. Machines that combine ultrasonic cavitation with rinsing and thermal disinfection are highly specialized and complex units specifically designated as ultrasonic washer disinfectors, distinguishing them from standard sonic tanks. Question 9. An environmental services technician is reviewing the infection control policy for the decontamination area. What is the required frequency for cleaning and disinfecting the horizontal stainless steel worktables where soiled instruments are sorted? A. Once per day during the overnight deep cleaning shift. B. Only when visible blood or organic soil is present on the surface. C. Exclusively after processing trays from known infectious isolation cases. D. At the beginning and end of every shift, and immediately whenever visibly soiled. Correct answer D. Knowledge point explanation. Core rationale. The decontamination area handles the highest concentration of biohazards in the department. Due to this severe environmental bioburden, horizontal work surfaces must be continuously managed to prevent cross-contamination. Facility protocols dictate wiping these areas down with a hospital-grade disinfectant at the start of a shift, at the end of a shift, and instantly if gross soil spills occur. Trap analysis. Option A is insufficient. Waiting 24 hours between cleanings in a high-traffic decontamination room allows massive microbial proliferation and increases staff exposure risks. Option B relies solely on visible dirt, ignoring the fact that microscopic pathogens from aerosols rapidly settle on these horizontal surfaces without leaving visible traces. Option C is incorrect because all incoming surgical items must be treated as equally infectious under the principle of standard precautions. Concept extension. The floors in the decontamination area must never be dry swept, as this kicks contaminated dust into the air. They must be wet mopped daily. Question 10. Why is the manual removal of gross, visible soil from a surgical instrument an absolute prerequisite before placing the device into an ultrasonic cleaning tank? A. Heavy soil quickly depletes the water's dissolved oxygen, halting the degassing cycle. B. Large amounts of organic debris will rapidly contaminate the solution and significantly reduce the efficacy of the cavitation process. C. Unremoved blood will chemically react with the stainless steel to create permanent rust spots. D. Excess bioburden causes the ultrasonic transducer to overheat and exceed the required 180 degrees Fahrenheit parameter. Correct answer B. Knowledge point explanation. Core rationale. Ultrasonic cleaners are engineered for finite, microscopic cleaning of hard-to-reach areas, not for massive debris removal. If instruments loaded with chunks of tissue or clotted blood are placed in the tank, the soil rapidly clouds the water. This suspended physical mass absorbs the sound waves, cushioning the cavitation implosions and rendering the machine ineffective. Trap analysis. Option A is fundamentally backward. Degassing is intended to remove dissolved oxygen, not preserve it. Option C is incorrect. While blood is corrosive due to chloride content, it is the interference with cavitation, not immediate rust, that mandates gross soil removal prior to sonication. Option D is completely false. Ultrasonic transducers do not overheat from soil, and standard sonic baths operate far below 180 degrees Fahrenheit, usually between 100 degrees Fahrenheit and 140 degrees Fahrenheit, to prevent enzyme destruction. Concept extension. Pre-rinsing to remove this gross soil should always be performed with cool or tepid water, never hot water, to prevent the coagulation of protein-based soils.